Welcome once again. Let's review. The low perturbation return in period t equals the low ideal beta plus the value of h in period t times the market perturbation return in period t. Although the sum of the h's is 0 in any given time period, we also saw that the individual expected h's do not equal 0. If the expected h does equal 0, then the expected return of the low CAPM beta portfolio in period t, given the perturbation return in period t, minus the risk-free rate, initially had this brief derivation. As discussed before, when the variance of h is included in the formula for perturbation risk, economic forces motivate the inclusion of a non-zero expected h for each portfolio, but the sum of the expected h's for all portfolios is 0. A complete return expectation conditioned on the perturbations whether 0 or non-zero is Note the difference between 22.2 and 25.1. The only difference is in the conditional expectations, where 22.1 does not have an h term, while 25.2 does. 25.2 is the correct conditional expectation, 22.1 is not. An alternate equivalent expression is the expected return of the low CAPM beta portfolio in period t conditioned on the perturbation return minus the risk-free rate equals the ideal beta times the excess return of the market plus the expected perturbation alpha, also conditioned on the market perturbation return. Where the expected perturbation alpha in period t conditioned on the perturbation return of the market in period t equals the expected h times the market perturbation return. Which expression someone chooses, 25.1 or 25.3, is a matter of taste. My opinion is that 25.3 is more natural since it contains the return of the market minus the risk-free rate rather than the ideal return of the market minus the risk-free rate. Is positive perturbation alpha a good thing? This was covered in video 22, but I thought I would reiterate the point. A negative h means a smaller positive perturbation when market perturbations are positive, and a smaller negative perturbation when market perturbations are negative. For a long-term investor, this means lower volatility for the same arithmetic mean return, which in turn means a higher CAPM alpha, a higher Sharpe ratio, and a higher geometric return than other investors with the same arithmetic mean return but with a positive h. In video 12, the formula for conditional expected CAPM alpha was: more generally, expected CAPM alpha should be written like this. Realized CAPM alpha has this form. Or alternatively, this more general formula includes the possibility that the average perturbation is 0, while the average low perturbation alpha equals minus the average high perturbation alpha, which is not 0. This concludes the discussion of the broad patterns of CAPM alpha. Here is the overall conclusion. The consistency of these two realizations in a generally rising market has been shown to be the result of these two expectations, which are natural to the structure of stock market return data without reference to financial analysis, accounting data, or economic forecasts. It was stated in video 9, to the extent that 9.6 and 9.7 can be expressed as mathematical expectations ex ante, the volatility effect is resolved. The goal of this series of videos has been reached. We still need to talk about individual stocks.